All right, so I promised you guys a video on covalent bonds, so here it is. Covalent bonds are only made of one type of atom. They're made of atoms that want to take electrons. So I'm being consistent with my color coding. In my previous video, I used red to describe atoms that want to take electrons. And I talked about how atoms that want to take electrons are typically nonmetals. So any elements above our stair step or to the right of our stair step, we could say is a nonmetal. So I'm really referring to everything over here that I'm outlining in red. I didn't go right up to the stair step because those are metalloids that are along the stair step. So they kind of sometimes behave like metals and nonmetals. So it's not quite as clear. But nonmetals are good electron takers. So I'm going to write that up here. Nonmetals are good electron takers. So we're going to look at an example of a covalent bond between bromine and bromine, my favorite element on the periodic table. So bromine can bond to itself. It's called diatomic. That's why it's a part of Brinkelhoff. We've talked about that. Bromine has 7 valence electrons because it's in the halogens group. So this bromine atom has 7 valence electrons, and this bromine atom also has 7 valence electrons. Now, since these atoms are both electron takers, neither one of them is going to be willing to give up an electron to fill their octet rule. So what they're going to do instead of giving up is they're going to decide to share. So this electron is going to spend equal amounts of time between the two bromine atoms, and this electron is going to spend equal amounts of time between the two electrons. And we see, instead of a transfer, we see sharing of electrons. So whenever there is sharing of electrons, that is called a covalent bond. Ionic bonds are full transfers, but covalent bonds are sharing of electrons. Now, covalent bonds are always between nonmetals. If there's one thing we get from this page, it must be this. Covalent bonds are always going to be between nonmetals. So let's talk about some properties. So, as far as my structure goes, my structure can be kind of confusing. So this molecule we've actually already talked about. This is a water molecule, which is H2O, and it's held together by covalent bonds. This molecule over here is actually an organic molecule between carbons and hydrogens. It makes a long chain of carbons and hydrogens that we call an organic molecule. Organic chemistry is kind of the chemistry of life. Oops, I didn't mean to write chemistry. I meant to write molecule. So organic chemistry is chemistry of organic molecules, and you and I are made largely of organic molecules. So for people who really like biology, OChem is how you would abbreviate organic chemistry. Is typically one of their more preferred classes because it's very applicable to life science. Now, notice I use the word molecule. We call particles held together by covalent bonds molecules. So these pictures that I have are pictures of molecules. So I'm going to even define it right here. Molecules are atoms held together with covalent bonds. Now, covalent bonds are not easy to break, but molecules are easy to separate. It's very easy for me to take one molecule and separate it from another molecule because they're not bonded together. There are some connections, but they're very, very weak. So let me show you what I mean by molecules are easy to separate. If I were to draw a water molecule, let's say this guy and this guy, boom, there's a water molecule. And let's say I were to draw another water molecule somewhat close to it. where it looked like this was maybe the solid phase. It would not take a lot of energy for me to take this water molecule and move it all the way over here so that now my water is in the liquid phase. And it wouldn't take that much energy for me to take this water or this water molecule and separate it even further so that now my water is in the gas phase, because there's no bonds holding one molecule together with another molecule. Your covalent bonds are between the atoms inside of the molecule. So since molecules are easy to separate from one another, covalent compounds typically have low melting and boiling points. This just means that I don't have to put in a lot of energy to melt or boil water. I can really get it to a very low temperature, and that amount of energy will be just enough to separate the molecules and melt or boil my substance. Now, covalent compounds tend to be very brittle. Covalent compounds are typically the things that you would see in a ceramics class. So a lot of your glassware and ceramic pots and mugs and things that you make in there are made of covalent compounds. When they're in the solid phase, they're very brittle. Now, sometimes they're soluble. What I mean by that is sometimes they dissolve, but not always. So this is definitely an emphasis on sometimes they're able to dissolve. Now, as far as conductivity, they are bad, always. Whether they're solid, liquid, gas, doesn't really matter. Covalent compounds are typically very bad conductors. So this wraps up our video on covalent compounds. Go ahead and tune in for the last video on metallic